Hello everyone, my name is Mr. Bryce and we're giving away free samples today of mathematics. Okay, the free sample today is variability and sampling, Common Core Algebra 2, the non-Regents version. If you don't understand what I'm saying, you can scan that QR code and the genius who wrote these worksheets can explain it to you. So what we're going to be doing is we're going to be talking about statistics. Statistics. That is looking at the data and trying to figure out how to present it in a meaningful way. Statistics. Data is everywhere. It's in our newspapers, it's in our science classes, it shows up in economics and in medicine, and anywhere there's variability. In other words, things can change, they're not consistent. Variability is simply the property of outcomes being different. The tools of statistics are designed to explain this variability. You're already familiar with many of the tools of statistics. Before we get into the tools, let's explain about the different types of variability. Okay, things can vary because of different factors, and we're going to try to separate those into categories. It's good to understand these sources in order to minimize the ones that we're not studying. Okay, so we're going to try to eliminate different types of variability if we want to examine or we want to know what's going to be happening. The following types of variability can change the uniformity of a data set. Do we want heterogeneous? Do we want homogeneous data? For each given example from any field. Okay, observational or measurement in variability. Variability is introduced due to either our measuring instruments not being precise enough or differences of how two people read the measurements. So it says, give an example from any field. Where can we have a measurement variability? Well, the obvious one is science class and the type of scale. And what I mean by scale is we're measuring, do we have a scale that only measures the nearest gram? Do we have a scale that measures to the tenth of a gram? Natural variability or inter-individual, between individual variability. This variability accounts for the fact that members are, well, people are different, fish are different. You can have like different fish growing at different rates, same type of fish growing at different rates. So we can do something like 75 fish eat the same amount of food, but grow at different rates. Induced variability. This type of variability is marked contrast to natural. Okay, it occurs because we've assigned our population or sample to two or more treatment groups. So induced means we're forcing it. We're forcing variability. So two groups are fed, so let's say G1, high protein. Group 2 is high carb. Which one runs the fastest mile after on the diet 8 weeks? That's forced or induced variability. Sample variability. So we're going to take samples at different times, multiple samples. Okay, and so what's happening? It's random. So let's see. We call people at various times in the day and night. We're going to have a different population at 1 o'clock in the afternoon than 8 o'clock at night. Okay, we're going to have people that work different shifts, people who work the day shift, people who work the night shift. So that's sample variability, but that doesn't mean that they're going to vote for someone different, or one group is going to eat more potato chips, or they like Pepsi versus Coca-Cola. Okay, not because of the time of day, but we're going to try to get a total sample. Okay, remember, through all of our work in this unit, we're really trying to explain the variability of the data within a population, everyone, or a sample, part of it. We're going to use this to determine if the variability can be attributed to one of the factors above to the exclusion of the others. It's important to understand those examples and definitions. Next page. Okay, so we're going to be talking a lot about data in this unit. And there are many different situations in which we collect data. There are many different ways that we collect data. And there are important differences, all of them. And it depends on the randomization. Unless we're going to take the whole population, if we're just going to take a survey or part of the population, we have to make sure it's random that we collect it. Must be random. So how do we make things random? If we do a survey, how can we make sure that it's random? We collect data from a population where variability is not induced by the treatments, but by the sample itself. So let's give an example of something that is a survey that's random. A TV station or a TV network wants to add a new program. So they survey people in a mall. Okay, that's going to be trying to make it random. Hopefully we're going to have different age groups in that mall. If you go to a mall and there are a whole bunch of teenagers, skateboarding all over the place, that is not going to make it random. You have to observe it, make sure that there's going to be a huge age group difference, or maybe a grocery store or something like that. But what won't make it random, wrong, is a survey outside a ball field, because they will just want a sports channel. Observational studies. Collection of data from a population where the assignment of individuals from the population into the groups is not under the control of those performing the study. So let's say, for example, that the government wants to find out if income affects obesity. Okay. Okay, does income affect obesity? So what are they going to do? They want to make sure that they have a cross-cut of income. So the survey has to have an equal or near equal amount of people in all income levels. Okay, experimental studies. In experimental studies, individuals are assigned randomly to treatment groups in order to determine the effect of a treatment on the variability of the data. In these cases, the assignment, although random, is under control of those performing the study. Is that really a lot different from B? Yes, let's take a look at how it's going to be different from B. In B, we wanted to make sure that we had an equal representation from all the different types. In C, um, let's say that 40 fish are divided into two groups. One fed golden pearls. That's the name of a food. The other, live shrimp. And what we want to do is we want to determine the growth rate. Okay, so here, we're not making sure that we have, it's not the population that's changing, it is what we're doing to the population that's changing. Okay, so that's an experimental study. Okay, we randomly assign them, we net out 20 fish from a tank, and we just dump the first 20 into tank A, and then same tank we take 20 out and dump 20 into tank B. So we have the main breeding tank, might have 200 fish in it. We take 20 out, put into tank A, to another 20 out, put into tank B, and then the experiment is going on. We didn't select the individuals. In B, we're selecting individuals to make sure that the study is going to be valid based on the preconditions of the study. The preconditions of the study in B is income affecting obesity. Here, there's only one variable, and that's growth. Again, we're comparing the two foods. Here, we're comparing income and obesity. This is 2 dimensions. This is 1 dimension. Okay? Random sampling is critical for being able to minimize the variability due to a bias in the sampling. Random sampling can be done using a variety of different techniques. Simple random sampling can be accomplished using a random number table. I used a random number table. For example, the phone book. The phone book is random number table. If you want 1 to 100, you can look at the last 2 digits of the telephone numbers. You just randomly open up to a page, go down, and the last 2 digits of the telephone number can give you numbers from 0 to 99, which is the same as 1 to 100. Double 0 is 100. A list of 10 people's heights in inches is shown below. Got it? Randomly select 5 heights from this list by using the random number table that goes with this lesson. So here I grabbed a random number table. And what you can do is you can say, oh, well, today happens to be April 6th. So I'm going to take the 6th one from the left. 1, 2, 3, 4, 5, 6. My numbers are 8, 3, 7, 7, 5. And since one of the numbers repeated, we'll go to the next number, which is 2. We will cross out one of the 7s. 1, 2, 3, 4, 5, 6, 7, 8. There's one random person. The 3rd is a random person. The 7th is a random person. The 2nd and the 5th are all random people. Question B asks us to calculate the sample mean. So out of that sample, we take the average, add them all up, hit equals, divide by 5, we get 62.5. So what's this underneath here? Well, what I did was I took the numbers that I didn't sample, I took the other 5, and I found their mean. You will notice that they are different numbers. Okay, that is a sampling difference, okay? The difference in those is just because of the sample that was taken. So that's right here. That's a sampling variability. It's an example of a sampling variability. That ends Unit 13, lesson number 1. You know the next 2 pages are homework. I'll see you later.